Hi everyone, welcome back. Today we're going to be looking at standard 7.rp.a.2, recognize and represent proportional relationships between quantities. Let's take a look at our vocabulary terms. So the first one is ratio, is a comparison of two or more numbers that indicates their sizes in relation to each other. A proportion is where two ratios or fractions are equivalent. For example, A over B is equal to C over D, or the ratio of A to B is equal to the ratio of C to D. Proportional, quantities that have the same relative size, they look different, but they have the same ratio. So take a look at these two teddy bears. These two teddy bears are considered proportional. Although this one is clearly smaller than this one, the dimensions, when simplified, are equivalent. Now let's ask ourselves, are ratios proportional? To answer this question, we can use cross products, also called cross multiplication, to determine whether or not the ratios are proportional or equivalent. In our previous lessons, we've talked about proportions before, so we know exactly how to do this cross multiplication, which we also sometimes refer to as the butterfly method, because the action of cross multiplying kind of look like butterfly wings. So using these variables, when I cross multiply and I multiply A times D, I get AD. And if I multiply C times B, I get CB. So A times D is AD, C times B is CB. Now, if both of these numbers are the same, that means that these two ratios are indeed proportional. Are these ratios proportional? Prove it. So let's go ahead and set up our fractions in the form of a proportion, and then we're going to use our cross multiplication to see if they are indeed proportional. So 5 over 3 is equal to 25 over 15. So to use cross product or cross multiplication, I'm going to multiply 3 times 25 or 25 times 3 and 5 times 15. So that was 5 times 15 is equal to 3 times 25. Let's try it out. 5 times 5 is 25. 5 times 1 is 5 plus 2 is 75. 3 times 5 is 15. 3 times 2 is 6 plus 1 is 75. So here we have that the numbers are the same on both sides, so this is indeed proportional. Some of you may be asking, is there another way I could have gone about this? Absolutely. So you could have also tried simplifying. So here, 5 over 3 is already in its simplest form, but could I have simplified 25 over 15? Absolutely, but sometimes it's just not as easy to simplify, and that's where the cross product will always be a proven method. So here it's clear that I can easily simplify 25 and 15 by using the number 5. So I can say 5 over 3 is equal to 25 divided by 5 is 5. 15 divided by 5 is 3. So here we have equivalent fractions, and that confirms that these two ratios are indeed proportional. But in some instances, it's not that easy to simplify, and in those situations, then cross multiplication is a proven method. Let's go ahead and take a look at our next example. So we have 6 over 9 is equal to 48 over 52. So here we have some big numbers, 48 and 52. If you wanted to try simplifying, you absolutely could. But let's go ahead and try our cross product first, and then we can take a look at simplifying. So 6 times 52, 9 times 48. 6 times 52, so we rewrite it. 9 times 48. So 6 times 2 is 12, carry the 1. 6 times 5 is 30, plus 1 is 312. Now let's go ahead and do 9 times 48. 9 times 8 is 72. 9 times 4 is 36, plus 7 is 43. So here we have that these two are not equal because 312 is not equal to 432. Now, if we try to use the method of simplification, so we have 6 over 9 equals 48 over 52. Now, 6 over 9 can be simplified, so 3 can go evenly into each of these numbers. So 3 goes evenly into 6, and it also goes evenly into 9. So that would be 2 over 3. And the largest number that I can think of that can go evenly into 48 and 52 is the number 4. So 48 divided by 4 is 12, and 52 divided by 4 is 13. So here I'm proving once again that these ratios are not equivalent because 2/3 is not equal to 12 over 13. So this here is not proportional. And this would be our proof to show that it's not indeed proportional. Now let's talk about finding an unknown. So it says what value for x would make the relationship proportional? So we're going to use the same approach that we did in the previous examples of cross multiplication. So 4 over 10 is equal to 32 over x, and I want to know what that x is. In order to figure it out, I'm going to cross multiply. So I'm going to multiply 10 with 32 and 4 with x, and use my knowledge of solving equations to find the value of x. So 4 times x is 4x. 10 times 32 is 320. And in order to get this variable x by itself, I'm going to divide both sides by the number 4. 4 divided by 4 is 1x. 320 divided by 4 is 80. So for this example, the value of x that will make this relationship proportional is 80. Let's take a look at our next example. So k over 3 is equal to 90 over 10. And again, we're going to use our cross multiplication. So k times 10, 3 times 90. 10 times k is 10k. 3 times 90 is 270. We're going to go ahead and divide both sides by 10. 10 divided by 10 is 1, so this is just k. And 270 divided by 10 is 27. So the number of k that will make this relationship proportional is 27. And if we wanted to prove it, then we can go ahead and plug that in and simplify the ratios. So 27 over 3 equals 90 over 10. So we can go ahead and use our cross multiplication. 27 times 10, I happen to know, is 270. 3 times 90 is 270, so it definitely works out as a check. We can also try simplifying. So 27 over 3 equals 90 over 10. 3 goes into itself one time, and it also goes evenly into 27. So 3 divided by 3, 27 divided by 3, that will give us 9 over 1. And here 10 goes evenly into itself, and it also goes evenly into 90. So 10 into itself is 1, 10 into 9 is 9. So here again, we see that they are indeed equivalent. Thank you for watching and have a wonderful day.